Paper-based origami battery that operates on the respiration of microbes. There's so much we could do with paper, but imagine it being a power source or a battery. This idea I am about to present will be capable of saving lives. The main idea is a battery made mostly out of paper. Of course, it has other parts. An air-breathing cathode made by spraying nickel on one side, an anode screen printed with carbon paints, and an area for where we can apply water laced with respiring bacteria. In other words, by applying bacteria to the device, it generates enough power to act as a battery and make low-power electronics such as biosensors run. If the idea is fully developed, it will be revolutionary, eco-friendly, and affordable. In other words, cheap, green, and effective. Revolutionary because ideally it should change how we conduct diagnosis in developing or remote areas, places where access to resources and technology is limited. And through this, the inventor hopes to revolutionize healthcare by providing a quick and cheap disease diagnosis and in turn save a lot of lives. Eco-friendly, obviously, because it is mostly made out of paper, which is biodegradable, and it is activated by bacteria, which can be found in nature. Affordable, again, because it is mostly made out of paper, which is very cheap, and the inventor claims it to cost as low as 5 cents per battery. The minds behind this invention are Choi and Lee from the Binghamton University in New York. The innovation of these two ECE experts proved to be a good one, since the National Science Foundation has given them a grant of $300,000 to further work on their research and make it commercially available. For now, the final product has no patent yet, but a similar patent, also by Choi, looks like a prototype for what they want to achieve. This patent and some other papers show that Choi has been working on harnessing power from bacteria for quite some time now. Their patent on micro-sized microbial fuel cell describes basically the same idea with the paper-based battery, except that it isn't paper-based. The main idea behind their device, and the device in the patent, is being able to use the energy coming from bacteria respiration. The device in the patent makes use of a type of microbe called the anode respiring bacteria. It has other names, but basically, they are bacteria which can transport electrons extracellularly. This will be clearer later on. The device showed a maximum output of about 400 millivolts with a power density of 4.7 microwatts per square centimeter and a current density of 12 microamps per square centimeter. In order to get an idea of how it works, let's first recall how a battery operates. A battery is composed of an anode, a cathode, and an electrolyte separating those two. Once the cathode and the anode are connected, like placing an electric device in between them, just like the light bulb in the picture, electrons will start to flow, thus giving the connected device enough energy to operate. In that sense, the use of the electrolyte, then, is to prevent the electrons from directly flowing from within the battery. Now, as we've noticed, electrons play an important role in the operation of the battery. But if we also recall our cell biology, electrons also play an important role in cell respiration, as this is the final product of it. Usually, most of the cell respiration process happens within the cell, specifically within the mitochondria. But there are special types of microbes, such as the anode respiring bacteria, wherein the final electron acceptor in the electron transport chain is found outside the cell. So basically, since we already have a means to produce the electrons, all we need is a positive terminal to connect it to, and now we have a battery. As for the applications, how I see it is that this invention, once it is fully developed, will pave way for other devices which can fully interact and is compatible with it. The inventors envision a system which can support its own and only relies on this paper-based technology. Once that is achieved, it will prove to be useful in places where technology, electronics, and resources are very limited, and potentially could save a lot of lives. Again, this has been my report on the idea of a paper battery powered by bacteria. Thank you for listening.